Alrighty, so we're on to 5.3 day 2, which we're going to talk about a new operation called composition, which basically is sort of a glorified substitution. It's where you do one operation or one function and then another. So it's sort of like when you're calculating a sale price with tax. We calculate the sale price first, and then we take that answer, and then we calculate the tax based off of that. So that's really what composition is, when we do one operation and then another. So we're going to talk about the definition of it, and then make sure we understand how that's going to work for us. So here's the definition of what composition is. So we're going to use two function names again, f and g. Doesn't have to be those two, but that's what we're using. The composition, so the open circle is the symbol that you're going to see. So open circle, so that would be f composed with g, can be described by this equation. I'm going to have you box or circle or star or highlight or something that f open circle g is read f composed with g, f composed with g. So like addition, subtraction, this is a new operation symbol. Open circle means composition. What it means is f of g of x, which basically just means substitute. So I'm just going to kind of describe, if you want to jot down like the process here. We substitute g of x into the function f for x. So it's a replacement, it's a substitution, f of g of x. So the way I would say that, this second part of it, I would say f of g of x. That's like how you say it out loud, f of g of x. So you take that second function and you substitute it. So whatever comes second gets substituted into that first function name. So it's like you do the operation. Think of it like order of operations. You would start with g of x, right? You start with what's on the inside and you work your way out. So sort of order of operations there. We're going to start with it with numerical values, and then we'll work into it with just the variable x, just to practice what that function means. So here's what we're going to take a look at. We're going to do two functions. So we're going to do f of x, which is this 2x plus 1, and then g of x, which is that trinomial x squared minus 2x minus 4. We're going to practice what it means to do each of these operations and make sure that we're okay with what that is. So if we read this, so f composed with g, open circle, notice that's that new composition of functions, open circle. So f composed with g of 5. What does that mean? Let's write the definition. That means f of g of 5. So that means I'm taking the function g first and plugging 5 into it, figuring out that answer, and then taking that answer and plugging it into f. So I'm starting with g of 5, working on the inside first, and then I'm going to figure out my answer and plug that into f. So order of operations, do what's on the inside first. So I'm going to do f of, and then let's just do that evaluation. So g of 5. So I'm going to use this function over here, this g of x first. Oopsie daisy. And I want to find that value at 5. So I'm going to do g of 5. So that's like putting in 5 here and figuring out what that would be. So that means that's 5, not 3. Goodness. So 5 squared minus 2 times 5 minus 4. So I'm going to do that operation. So I'm going to start with g of 5, and I'm going to calculate that value. All right, so I'm going to go ahead and move these out of the way here again. Okay, so then I'm going to go ahead and evaluate that. So let's see what that number is on the inside. So 5 squared, 25, minus 10, minus 4. So 25 minus 10, 15, minus 4 would be 11. So this means I need to do f of 11. Okay, so f of 11 means I'm going to be using this function rule f of x, and I'm going to be putting 11 in for x. So it's kind of like you start with the one function, and then you get your answer, the 11, and then I'm going to do that substitution. So now f of 11, that means substitute 11 in for x, so 2 times 11 plus 1. So 2 times 11 would be 22 plus 1 would give us a grand total of 22. So our final answer for that one would be, looks like 20. Oh my goodness, 22 plus 1, help me. So 23. Brain is shutting off here at the end of the day. So 23 would be our final answer. So f composed with g of 5 would mean 23. I start with g of 5, and then I plug that answer into f. Let's try another one just so we can keep practicing that and see what happens when we do it with a little bit different numbers. So f composed of g of negative 5, what would that mean? Well, that would mean f of g of negative 5. So we're going to start with the function g, since it's on the inside, and we're going to figure out what the value of g of x is when I plug in a negative 5. I'm going to get rid of a little bit of this writing up here so we can see these. So we're going to work with our g function in the yellow box here. So we're going to work with that one. I'm going to plug in -5. So the rule for g says, okay, I'm going to plug in -5 for the x and square it, minus 2 times -5, and then -4. Go ahead and pause the video and see if you can figure out what that value is for g of -5. So I'm evaluating g at -5, which means do this, and see what you get. All right, so it looks like when I put that all together here, looks that would be 25 plus 10 minus 4, so 31. Double check my arithmetic there and see if that works out. And then now I'm just going to do f of 31. So that means I'm plugging in 31 for x in the function f, just like our normal function notation. So 2 times 31 plus 1. So it looks like that would be 62 plus 1, or a grand total of 63. So composition just means a substitution. We're substituting into the second function and then into the first, taking that answer. Now let's do this in terms of just x. How would it look if I wasn't actually doing it at a function value, a particular number? I'm just going to use the variable x. So this would mean f of g of x. So notice the second function is the one that's getting substituted. So that means I'm doing f of the entire rule for g of x. So g of x is this whole thing, right? So this is the whole rule for g of x. I'm going to be replacing it into the function f for the x. So I'm really going to be doing f of x squared minus 2x minus 4. So the rule for f says, okay, I'm going to take 2 times whatever I substitute. If it's a number, that's a lot easier, but it's this whole thing. And then the rule says after that, plus 1. Okay, well, I can simplify that a little bit, but that's what f of g of x means. It means take the rule for g and substitute it into the function f for the x. So if I simplify that down a little bit, I can distribute here. So that would be 2x squared minus 4x minus 8. And then don't forget the plus 1. I can add that on. So 2x squared minus 4x minus 7 would be f composed with g of x. I can actually do it for the whole rule with just x, or I can do it with specific values. So our practice, our plan is we're going to really try to see if we can kind of conquer this whole substitution idea, composition. Whatever the second function is, it gets substituted. So let's practice with another one so we can do a little bit more here. So we're going to do g composed with f this time. So now we're going the other way, of 3. Okay, so what's the difference if I do g of f? Well, that means instead of putting the function g into the function f, the f is coming second. So that would be g of f of 3. I'm going to go the other way. I'm going to start with the function f and figure that out first and then plug it into g. So I need to start with whatever f of 3 is. So on the inside here, that means I'm going to be using this function f, and I need to plug in 3. That's what that means. So using this rule, that means 2 times 3 plus 1. So I need to figure out 2 times 3 plus 1. Okay, so let's go ahead and do that. So 2 times 3 plus 1 looks like that would be g of 6 plus 1, 7. So I need to do g of 7 now. So g of 7 means I'm going to take that answer that I just got, that 7, and I'm going to plug it into g. So g of 7. So I'm going to be doing that rule. So I'm going to have 7 squared minus 2 times 7 minus 4. So 49 minus 14 minus 4, and put that all together. 31, double check my arithmetic there. So g composed with f of 3 means instead of doing g into f, I'm doing f into g. Whatever comes second gets substituted. So you start with f of 3, do that arithmetic, get your answer, and then I do g of that answer. So that's why I did g of 7. All right, well, we can do this in general as well. We can still do g of f of x. Remember what that means? Just g of f of x. In other words, I'm going to take the whole rule for f of x and substitute that in there. So I can take that whole rule for f and plug it into g. So what does that mean? Well, the whole rule for f is this line, this linear thing, and I'm going to replace it into the function g everywhere you see an x. So it's like you're doing g of this 2x plus 1. I'm going to actually substitute in the 2x plus 1 into the function g. So I'm going to plug it into both of those locations. So I'm doing g of this whole thing 2x plus 1. All right, so what would that look like? Let's see if we can write that out. So function g says take, hey, whatever you're substituting and square it. So I'm substituting the 2x plus 1, and I'm going to square that. And then it says, okay, minus 2 times what you substitute. So minus 2 times that whole function f. So minus 2 times that, and then minus 4. No variable there, so nothing to substitute. Now that's what g composed with f would look like. I'm plugging in the function f into the function g instead of going the other direction. Now, that's kind of messy. That's kind of a big mess there. We can simplify that some, so let's see if we can do some algebra here. Do you remember what it means to have a binomial squared? It means I need to do FOIL. So that's like 2x plus 1 times 2x plus 1. I'm also going to need to distribute out here, so I'm just going to go ahead and do that. So minus 4x minus 2, careful, it has to distribute to both. And we just have our minus 4. All right, so can we go ahead and do this FOIL here? First, outside, inside, last. 2x times 2x would be 4x to the second. And then the outsides would be a 2x. Inside's another 2x. And then last, 1 times 1 would be 1. And I'm just going to recopy everything else. And then we can go ahead and put together our like terms. So g of f of x. Okay, let's see what we get for our like terms here. Looks like the only squared term I have is the 4x squared. And then looks like we have a 2x and a 2x and a minus 4x. So what happens there? Got nothing left there at all, do I? So I don't have any x terms left at all, so that would be a 0. And then, looks like I have a 1, minus 2, and a minus 4. So negative 6 plus 1 would be minus 5. So 4x squared minus 5. So we can do composition just with a variable x, so we have just the general rule, or we can do it with a numerical value. But remember, whatever comes second, that's what you're substituting into the other function. All right, so let's do a quick review of all of the operations that we've talked about so far in this section. So we're going to start with seeing if you can figure out what each of these mean. And these are the two functions that we're doing. This is the function f of x, and this is the function g of x. I'm going to try to keep my color coding here. Go ahead and pause the video, see if you can do this first one, and then I'll talk it through. All right, so what does that mean when you see the plus sign in between? That means you're taking the function f of x and you're adding it to the function g of x. There's no number in here, so we're literally just doing it with the rule and putting them together. So that means I'm going to take my rule for f and I'm going to add that to my rule for g. Okay, now because it's addition, I'm just going to look for like terms and put things together. There aren't any. There's nothing that's the same. I don't have the same power with the same variable, so I'm just going to write this in descending order. So what term would you write first if you're going to put it in descending order? Well, the x squared would have to come first, followed by the 3x, and then the minus 1. So try to write your answers in descending order. It just makes life a lot easier. So that was just an addition of two functions. Okay, go ahead and pause the video, see if you know what this means, and give it a whirl. All right, so we're subtracting, so that means we're taking the rule for f minus the rule for g. So really similar kind of operation, but we're subtracting. So we're taking 3x, and we're going to subtract g of x, which is the x squared minus 1. Now in this one, it's really important to realize that that subtraction, remember, it distributes to both terms there. So that means you'd have a 3x minus the x squared, which most people will probably get. Now careful on this one though, minus a negative plus positive. It does change that sign, so be aware that will be a plus 1. Okay, again, we want to do descending order, so even if it starts off with a negative leading coefficient, we're going to start with our highest degree term first, and then our linear term, degree 1, and then our constant. So notice we would have that those sign changes because of the subtraction. So that was what we did in day 1. Okay, let's see if we can figure out the difference between f of g and g of f. Okay, so f of g. What does that mean? Composition. Go ahead and pause the video, see if you can write out what that means. So that means f of g of x. All right, so that means I'm taking the function g, so I'll just do a little picture here. I'm going to be taking the function g and substituting it into the equation f for x. All right, so I'm going to go ahead and move this work here just so I have a little bit more open space around here so we don't have as much going on. You can see this a little bit easier. So that means I'm doing f of this rule x squared minus 1. I'm going to take that function g, the whole rule, and substitute it into the equation f for the x. Okay, so what does the rule f say? It says, hey, take 3 times whatever you're substituting. So 3 times whatever I'm substituting. So I'm going to substitute in that x squared minus 1. Now this one, there's just not a whole lot of arithmetic to do here. The only thing I'd probably do is just distribute that through. So 3x squared minus 3. So if you're doing this with the rule, you're actually putting the whole rule in. All right, so what's the difference then if I say g of f? How is that different? Pause the video and see if you can write out what that means. So g of f, the f is coming second. That means I'm doing g of f of x. In other words, I'm putting the function f into g. Okay, so what does that mean? That means I'm taking this rule f and I'm substituting it in place of the x in the function g. I'm substituting the other way. So I am doing g of whatever that f function is, which is the 3x. So I'm going to take this 3x again and I'm going to substitute it in place of the x in the function g. All right, so what does the rule for g say? It says, okay, you're going to substitute and you're going to square whatever you substitute. So whatever you're plugging in for x, you're going to square it, and then you're going to subtract 1. That's what the rule says. So that's what we're going to do, but with the 3x is what we're substituting, because that's your function f. All right, well, what's 3x times 3x? Well, it's 9x squared. And then minus 1. So we get a completely different thing. Often you're going to see that. F composed with G and G composed with F, not probably going to be the same function at all when you do those. Let's look at an application of this idea of composition. When we talk about iteration, that's a really great example of how we can see where an output becomes an input, where we do a function first and we take that answer and we plug it in to a new function. And that's really what you're doing when you do composition. So iterates are just looking at answers when we keep substituting into the same function over and over again. So let's talk about how we do that. So I'm going to give you this information right here. And this can be kind of confusing to people because of all the subscripts. But x sub 0 just means the starting value, like your initial number you're going to start with. So the starting value at time 0, like when you begin, it's the first number they want you to plug in. So x sub 0 means your initial value. So we only have one function, notice, because we're only going to be using this function. And we're going to use the same function over and over again. So to find the first iterate, or the starting number, x sub 0, we do f of 1 then, because they're telling us to use x equals 1. And we're going to plug it into that function, no problem, and we can get our final answer. Just normal function notation now, right? We're just plugging in a 1. So 2 times 1, 2, minus 3 would be a negative 1. Okay, so how do you find the next iterate? So I'm going to kind of color code here. So the next iterate is x sub 1. What is the x value I need? Well, it's the output from the original. So the output of that first answer becomes the input for the next one, the next iterate. So I'm going to take the same rule, this same function, but now I'm going to use that output from the first round, and it's going to become the input. So the answer for the first one becomes the input for the next one. And I still use the same rule, though. I'm still going to plug in to this same function. All right, so we can do that calculation. So 2 times negative 1, negative 2, minus 3, negative 5. Okay, so there's my output. My first, or my answer for my x sub 1 iterate here. So that's my output. All right, well, how do I find x sub 2 now? Can you guess? How would you find the second one? Well, the output here becomes the input here. So now I'm going to be using negative 5. Just like in the last one, my output for the first one became the input for the next one, same thing. So now for my second iterate, x sub 2, I'm going to be substituting in negative 5. So 2 times negative 5 minus 3. Notice we're always going back to this same line. So 2 times negative 5, negative 10 minus 3 would be negative 13. So there's my x sub 2. All right, and notice again, this is my output, right? That's my answer. So my output for the second iterate is going to become the input for x sub 3. So I'm going to be putting in negative 13 now. So to find this third iteration, I'm going to plug in negative 13. So 2 times negative 13 and then minus 3. So negative 26, 27, 28, 29, negative 29. And you could keep going. This output would become the input for the x sub 4, and so on. You could keep going. So iteration is where you're kind of just composing with itself. You're doing the same function over and over again. So the output for one becomes the input for the next one. So it's really just composition with a function itself. So the big idea for today is this idea of composing. F composed with G, being able to do that numerically, like when they give you a number like 5, or with a variable like x, being able to do that with just the rule. So remember, composition, the second function is what you're substituting first.